Hi, this video is on expected value, and we understand expected value as the average value of some variable when you do a large number of experiments. And I know it sounds very fancy, so to say, but to find the expected value, we calculate the product of the result of each outcome and its probability, and then all those products are going to be added together. Let's actually do a problem, and we'll see that it's actually pretty simple to do. So a particular spinner has three regions, numbered 1, 2, and 3. The probability of getting 1 is 1/8, the probability of getting 2 is 3/8, and the probability of getting 3 is 1/2. Note that all the probabilities add up to 1. We want to find the expected value. So here's how we're going to do it. We have an outcome of 1, times the probability of that happening, plus the probability, the second outcome is 2, times the probability of that, plus the outcome of 3, times the probability of 1/2. All you need to do here is compute that, and after computing that you are going to get 19/8. Or that number can also be written as decimals, 2.375. So what does that mean? It means that on average you will get 2.375. It's kind of hard to interpret that in the context of this problem, so we're going to get a chance now to see how these can be applied in some other situations. It's going to make more sense. So you offer to play the following game. You pay $2 to select a card. If you get a king, you win $20. Otherwise you win nothing, and we're going to figure out the expected value for the player. So here's how we're going to set up problems like this. We're going to take the probability of a particular outcome, and for that outcome we're going to calculate the gain minus the loss, then plus the probability of another outcome times gain minus the loss, plus etc., as many as we're going to need. So hopefully you have enough understanding of basic probability here. What's the probability you're getting a king? It's 4 out of 52, or 1/13. What do you gain if you get a king? You will gain $20. What do you lose? Remember, you're still paying $2 to play, so minus 2. What's another outcome? You don't get a king, right? Because you either get a king or you don't get a king. So if you don't get a king, the probability here is going to be 12/13. What do you win in this case? What do you get in this case? 0. What do you lose? Still the same $2. So you can go ahead and proceed with that. This here is going to give you 18/13, the first one, because this is 18 times 1/13. The second one is going to give us minus, because you're going to multiply by negative, minus 24/13, which is going to give you negative 6/13. So since you're playing here with money, we need to interpret that that way. This is approximately negative 0.46. Okay, so what does it mean? That means on average you will lose 46 cents per game. Okay, so understand this. If you play this game, you could play 2 times in a row and get a king each time. That's not impossible. It could be that you're going to get a king 3 times in a row. It's not a very likely situation, but it is possible, and you can walk away with $60 minus $6 that you paid. But we're talking about on the long run. So let's say you're going to play this game 1,000 times. So you are going to be losing as a player about 46 cents per game. Somebody offers you another game. So you pay $2 to roll a standard die. If you get 5 or 6, you win $5. Otherwise you win nothing. What's the expected value here? Well, the probability of winning 5 or 6 is going to be 2 over 6, right? What do you win in this case? You win $5. What do you lose? $2 that you pay to play. What's another outcome? You don't get 5 or 6. That's 4 possibilities out of 6. In this case, you win nothing. You lose $2 to play the game. So after doing all that, you're going to get negative 1/3. You can put it in the calculator and do that, which is approximately negative 0.33. Okay, so that means here on average you're losing about 33 cents per game. Alright, as you understand the concept of expected value better, the dealer proposes to change rules. You still pay $2, and if you get a prime number, you will win $4. Well, first of all, prime number, those are 2, 3, and 5 on the die, right? So, what we have half of them that are prime, half of them that are not prime. So, the probability is 1/2. If you get a prime number, you win $4, and your loss is going to be $2 that you pay. Plus, the probability that you don't get a prime number is also 1/2. In this case, you win nothing, and you're still paying $2 to play. So in this case, if you do all the calculations, this is going to give you 0. We call this a fair game. That means nobody has an advantage. Because here's what happens. If you play in this game, then you as the player have a disadvantage, and the house is going to have an advantage, because if you're losing 33 cents per game, they are winning 33 cents per game. Okay, but this problem, this example 2, the expected value here is 0, which means in the long run everybody's gonna be walking away with whatever they had. Okay, of course we don't only apply it to gambling. It's used in other areas of human lives. The insurance company sells an annual life insurance policy for $100 to 33-year-olds. In case an insured dies, the company will pay $10,000 to his or her beneficiaries. The probability that a 30-year-old is going to die is 0.8%. Find the expected value for the company. Well, 0.8% needs to be written as a decimals, which is 0.008. So that's the probability of the person dying. So 0.008. So in that case, for the company is going to gain $100 that they received when a person paid them for the policy, and they're going to lose in this case $10,000, right? Now, what's the probability that a person does not die? Probability does not die is going to be 1 minus the probability of death, which is going to be 1 minus 0.008, which is 0.992. So 0.992 is the probability that a 30-year-old is not going to die. And in that case, the company still has their $100 coming in, and they pay nothing. Okay. When you substitute when you put all this in the calculator, you are going to get 20. So what does this number mean to the insurance company? So they sell their policy for $100, and if they sell enough policy, they get to keep, on average, $20 per policy sold. Okay. Of course, insurance companies are not in business of trying to benefit people. They're in the business of making money as well. And so in this case, in this particular case, they will be keeping $20 per policy if they sell enough policies from each one out of the $100. Alright, an air conditioning company installs new AC units for $4,500. They sell a warranty plan also that will pay for replacing the unit in case if it breaks down. Out of 100 units, 1 unit requires replacement. The plan costs $80. Find the expected value for the company. So 1 out of 100 units is going to need replacement. 1 out of 100, so 100 is going to be the probability that the unit is going to break down. For the company, they're still getting $80 that requires you to purchase the policy, and they will have to pay out $4,500 because they will have to replace the unit. Plus, so 1 unit requires replacement, 99 other units are not going to require replacement, so 99 over 100 is the probability an AC unit is not going to break down. In this case, they still keep the $80, but they pay nothing. So you substitute, you put it in the calculator, and you're going to get 35. So what does that number mean to the company? They get to keep $35 per policy on average. So a couple of words about this. You should understand here, since they get to keep $35 out of policy, they're really only that means they're making money on this policy. And if they're making money on this policy, they know precisely what they're up against in case if you have a situation of a breakdown with the unit. And the way these things are calculated, like the cost of the plan is always going to take into consideration so that they are not going to be losing money on this, okay? Because they certainly don't want to sell you policy to replace your AC unit and end up paying for a replacement and not having any profit from this insurance, from this warranty plan. Alright, Math Club, the local high school wants to raise money to attend an out-of-state math competition. They're selling 1,000 raffle tickets for $4 each. There is the grand prize that they're gonna award, $1,500, and 2 small prizes of $200 each. So, what's the expected value here? Well, there's 1 grand prize out of 1,000, so the probability is going to be 1 out of 1,000. In this case, a person's gonna win $1,500 and they're still paying $4 to buy a ticket. Plus 2 small prizes, so 2 over 1,000 times this person's gonna win $2 and they're gonna pay $4 to play. Plus, so 1 grand prize, 2 small prizes, that's a total of 3. There's a 997 out of 1,000 who are gonna gain nothing and will still have to pay $2. When you do the computations here, this is going to be negative 2.1, which we interpret that as a loss of $2.10. So that means that as a player, you are expecting to lose $2.10, considering all the possibilities to win here. Here's an important thing that you need to understand. When you buy more tickets, you increase your chances to win. Absolutely, that's not a question here. But what is the expected value of buying 10 tickets? Well, the expected value of buying 10 tickets will be 10 times negative 2.1, which translates into $21. So in reality, the expected value of buying 10 tickets is going to be, it should be negative 21. So you expect to lose on 21 tickets $21. right? So what does that number mean? That means you expect to lose $21 from that. Okay, it's a very important thing to understand, because yes, you increase your chances, but you only have really 3 possibilities to win and 997 to not win. So expected value is going to increase, well, technically decrease, by buying more and more tickets. All right. Another insurance company estimates that 1 in every 5 customers gets into a car accident, and repairs are $2,500 on average. How much should they charge in premiums? So their expected value is $50. This is a fairly typical question when you actually need to find the cost of the policy. So what do we know? We know that the expected value needs to come out to be 50. How do we get that? So 1 in 500 customers, so the probability is 1 over 500, is going to get into a car accident. The insurance company wants to charge you a certain premium, which is going to be their gain, and they're going to have to pay out $2,500 for repairs plus. So the other 499 customers will not get into a car accident. So the probability here is 499 over 500. And what is the company doing? They're still charging you X dollars and they're paying nothing. This here will give you an equation that you solve. Okay, it looks a little unusual, but you distribute here times X minus 2,500 times X is going to be 5. I'm sorry, 2,500 divided by X. Plus here X minus 0 essentially is X, so you get 499 over 500 times X. These two things added together will actually give you X, and if you finish solving that, you get $55. So they should charge $55. So think about this. That means they're going to only lose from their policy, since their expected value is $50. They get to keep $50, and they're only expecting to lose $5 from that, from the money that they receive from each client. Okay, and I hope this was helpful.